You know, the Super Bowl's been often touted as a stock market predictor, which of course is absolutely absurd. And the idea has fallen out of favor, partly because, the last 20 years it hasn't worked so well. But I want to look at statistically to show why, even if so, it still is folly. Well, there's some 55 games in the Super Bowl so far, but let's make it 64 because it'll make the math a lot easier to handle. And about 3/4 of the time the stock market goes up year to year. Well, that's kind of expected because the stock market on average does go up. And about 3/4 of the time teams from the NFC win. And that was explained by the fact that they tend to come from larger cities, affording better players, albeit recently that has changed with some income distribution between the teams, but still, let's assume 64 cases. Well, be that as it may, if you have 64 cases and 3/4 of the time the NFC wins and the market goes up, you'd expect 36 of them to be correct. And likewise, if the AFC wins and the market goes down, you'd expect 4 of them to be correct, noting that you'd expect 12 cases where they were incorrect, the AFC versus the stock market going in opposite directions, and likewise the NFC versus the market going the other way. So thus you'd have a total of 40 correct cases, or 5/8 in total, and 24 incorrect cases, or 3/8 in total. And you'd say, well, gee, there's going to be a positive correlation. Or will there? And you might think the mean average would be 1/2, and no, it wouldn't. It'd be 3/4, let's say, counting the wins for the market and wins for the Super Bowl being 1s and losers for both being 0s. So the mean average for each is 75%, or 3/4. And we can skip the step regarding the variance and standard deviation because we're just going to go right to the covariance. Covariance is, well, how did they do relationship to each other? So let's take the average for, say, population A, maybe the Super Bowl, subtract it from each and every case. Population B, say the stock market, take the average for that, subtract it from each and every case, multiply them together, add them up, divide by the number of cases. Let's start with both of them being wrong. That's a quarter chance times a quarter chance. Remember, the mean is 75%. But we're talking about cases of zeros, so that's minus 75. But remember, it's minus times a minus, so it's positive, and we get 3/16. Then we got right versus right. The gee there, the case is 1, minus the 3/4, that's plus a quarter. Plus in both cases, times 3/4 times 3/4, you get plus 9/16. Now let's look at wrong versus right and vice versa. We have a 3/4 times 1/4 case, but notice it's wrong, so it's a minus sign. The average is 3/4, but we subtract 0, so we get a negative 3/4, minus 9/16. On the other hand, we have 3/4 times a quarter, and there that's the case where it's only 25% difference, but it's negative, minus 3/16. Look at that. Add them up, the total is 0. And to be fair, we would actually take the covariance divided by the standard deviations, which we didn't bother with. Why? Because we started with the 0 to begin with. And remember, that's in spite of the fact we had more cases on one side than another. Something to think about.